Welcome to our lesson on oxyacids. In this lesson, we're going to be talking about oxyacids, which are acids that are made up of hydrogen and polyatomic ions. This is not to be confused with our binary acids that we saw earlier. So binary acids were acids like HBr. So they're made up of hydrogen and just a nonmetal. So when you're naming a binary acid, you would name it as hydrobromic acid. So the naming is different for oxyacids where we don't include our hydro before it. So that changes things a lot. So let's start off by looking at 3 of the common polyatomics that we saw in our polyatomic ion lesson. So we'll get to the standard 5 later, but let's look at these 3 first. First of all, if you recall, the formula for acetate was CH3COO. And then you had your brackets, and it had a charge of -1. Dichromate was Cr2O7, and it had a charge of -2. And oxalate was C2O4, and it also had a charge of -2. So if you're making an oxyacid, or if you're making an acid, just like we did for the binary acids, we have to use the same thing we did for ionic compounds, really, which is we're taking the hydrogen and we're taking whatever our nonmetal is, or our polyatomic, and crisscrossing it. So hydrogen had a charge of +1. Acetate, CH3COO, has a charge of -1. So when you crisscross these, really you wouldn't have a number written down there, because when it's 1, we just don't write the 1. So we have H, which is from our hydrogen, and then our acetate, CH3COO. And when we make our oxyacid, we have to make sure that we have our hydrogen, right? And that's what's different between the ion version and our oxyacid version, that this is a compound. It has hydrogen in it. When you're naming it, as I alluded to earlier, we don't have our prefix. So instead of our prefix, we just say the name of our polyatomic ion, and then we end it with ic acid. So this polyatomic ion is acetate. So if we're changing the ending to ic acid, it would be acetic acid. All right, let's do the same for dichromate. So I'm going to pick maybe here. So we've got hydrogen, H+, and we've got Cr2O7, and this has a charge of -2. So when you crisscross these, we've got H2, right? This 2 is coming from the charge of dichromate. And then we've got Cr2O7. There's supposed to be the 1 over here, but because it's just 1, we don't have to put brackets, we can just leave it as is. So the formula for the oxyacid is H2Cr2O7, and when you're naming it, it would be dichromic acid. All right, let's do the same for our last one. H+1, C2O4, 2-. Again, we do the crisscrossing, H2C2O4. When you're naming it, the naming would be oxalic acid. All right, so those are 3 of the common ones that we solved. Let's go into our 5 standard polyatomic ions and see what the oxyacid formula would be and what the oxyacid name would be. So nitrate had the formula NO3. It had a charge of -1. So when this combines with the hydrogen, you would get the oxyacid HNO3. The reason is this has a charge of -1. Hydrogen has a charge of +1, and because they're both 1s, you wouldn't write any of the other numbers there. And when you're naming it, remember that this is a oxyacid, so we don't have the prefix hydro, which means our name is nitric acid. There we go. Let's try our carbonate ion. So CO3 2 minus. So when you do our crisscrossing, we would get H2CO3, right? So carbonate has a charge of -2. Hydrogen has a charge of +1. So when you crisscross those, this is what you'd get. The name is carbonic acid. Chlorate has a charge of -1, so we won't have any other numbers there. So HClO3, this is chloric acid. Sulfate, when it becomes an oxyacid, becomes H2SO4, which is sulfuric acid. Phosphate, when it becomes an oxyacid, becomes H3PO4, which is phosphoric acid. So these are our 5 standard polyatomic ions in its oxyacid formulas and as its oxyacid names. So you'll notice that there's no prefix whatsoever. The ending is ic acid. Now here's where things get a little bit more complicated. So when we're looking at our standard 5 polyatomic ions, there are variations of those polyatomic ions. And the variations that I'm talking about has to do with the number of oxygens. So our standard number of oxygens, when it forms a oxyacid, we saw that it was, so for example, let's take nitrate, right? So our nitrate ion had a charge of -1, right? When it formed the acid, it formed HNO3, and this was called nitric acid. Now, say for example, this nitrate, instead of having 3 oxygens, had 4 oxygens. What would happen then? So it would still form an acid. It's still possible. So the formula would be HNO4, but the name is going to be different, obviously. And the name is going to be pernitric acid. Say it's 1 less oxygen. So instead of it being NO3, it's NO2, 1 minus. Again, it does form an acid, HNO2. It's going to be, instead of it ending in ic acid, it's going to end in us acid. So it's going to be nitrous acid. And say it's 2 oxygens less, so instead of being NO3, it's just NO. It still forms an acid, HNO, and the name is hyponitrous acid. So if you notice, the charge of all of these variations of this nitrate ion is still -1. However, the name is different and the formulas are different as well. The oxygens, the difference in the number of oxygens is what gives us a different formula. So this is the rule that is in place for all of the 5 standard polyatomic ions. So for example, the standard one is always going to end in just ic acid. If you add 1 more oxygen than the standard, it would be per whatever ic acid. And if it's 1 less, it's going to end in us acid. If it's 2 less, it's going to have a prefix of hypo, and it's going to have a suffix of us acid. So what I want you to do is pause this video, and I want you to go into your notes, and there's a chart that's going to be blank for you. I want you to fill in all of the different variations for each of the 5 standard polyatomic ions, including the formula as well as the name. So this is going to take a while. So I want you to go do that and then come back, unpause the video, and watch the rest of it. Okay, so I'm hoping that you are finished your chart in your notes, completed. So let's look at what the variations of nitrate would be. So this is the one that we did earlier, but so our nitrate ion, NO3 with a charge of -1, when it becomes an acid, it becomes HNO3, and this acid is called nitric acid. let's look at a scenario where there's one more oxygen, right? So NO4 with a charge of 1 minus. When it forms an acid, it forms HNO4. Notice again that the charge does not change. The only thing that changes is the number of oxygens. And the name of this is pernitric acid. Okay, let's go into a scenario where there's one less oxygen. Again, charge does not change. There's just one less oxygen. The acid that it's formed is called HNO2. The acid is nitrous acid. And if there's two less oxygens, it would be HNO, and it's hyponitrous acid. Okay, let's look at carbonate. So our standard one is as follows. If there's one more oxygen, it would be H2CO4, and the name is percarbonic acid. If there's one less oxygen, it would be H2CO2 with the name of carbonous acid. If there's two less oxygens, it would be H2CO and hypocarbonous acid. So if we're looking at chlorate, our standard chlorate forms chloric acid, which is HClO3. If there's one more oxygen, it forms HClO4, which is perchloric acid. If there's one less oxygen, it forms HClO2 as chlorous acid. If there's two less oxygens, it forms HClO, which is hypochlorous acid. So looking at sulfate, when it forms an oxyacid, it forms H2SO4, which is sulfuric acid. One more oxygen would form persulfuric acid, which is H2SO5. If there's one less oxygen, it's H2SO3, which is sulfurous acid. If there's two less oxygens, it forms H2SO2, which is hyposulfurous acid. Going into our last one, phosphate forms H3PO4, which is phosphoric acid. If you add one more oxygen, it forms perphosphoric acid, which is H3PO5. If it has one less oxygen, it forms H3PO3, which is phosphorus acid. And if it's two less oxygens, it forms H3PO2, which is hypophosphorus acid. Okay, so that's all of the different variations. Hopefully you understand the methodology behind that, so you're not actually memorizing all of these. You don't need to. You should just know the standard ion and know that if you're adding an oxygen, then the acid that forms is going to be perphosphoric acid. If you're taking away an oxygen, the acid that forms would be phosphorus acid. If you're taking away two oxygens, it would be hypophosphorus acid. Also remembering that the charge stays the same. That's pretty much it for our oxyacid lesson. Please try and do as much practice as possible. The more practice that you do, the better you will become at this.